Study about the common emitter amplifier experiment. So in this let us start starting from the working principle of the CE amplifier and biasing techniques. I am not going to explain detail about that, it becomes almost theory subject. So exam point of view, I am going to explain what are the things you have to maintain and how to assemble on the breadboard as usually. In each and every video I am displaying here a pictorial diagram, and just follow this and you will get 100% outputs. Okay, before starting this experiment, let us understand what is CE amplifier. It is like this. The most common amplifier configuration for an NPN transistor is the common emitter amplifier circuit. Transistor amplifiers amplifies the input AC signal that alternates between some positive value and corresponding negative value. Then some way of presettings, the amplifier circuit configuration is required so that the transistor can operate between the two maximum and minimum or peak values. This can be achieved by using a process known as biasing. Okay, the output signal must be an expected reproduction of the input signal, but only bigger or amplified output. So if the amplifier is working as a truthful amplifier, means if you say that the amplifier is truthful, how to define that? When the input weak signals are given, the amplified output you have to get without changing the shape of the input signal. This condition, please note this point, these conditions we have to satisfy. CE amplifier has a resistor in its collector circuit. How this truthful amplifier can be achieved is some of the tips I am going to give here. CE amplifier has a resistor in its collector current. Here it is 2.2 kilo ohms. The current flowing through this resistor produces the voltage output of the amplifier here. The value of the resistor chosen so that at the amplifier quiescent operating point, this output voltage lies off a transistor load line. The base of the transistor is biasing using two resistors, a potential divider network. This type of biasing is very common in the bipolar transistor amplifier circuits and greatly reduces the effect of the reducing the beta value by holding the biasing a constant steady voltage. This type biasing produces the greatest stability. The emitter resistor is included in this as an external resistor. The voltage gain of the amplifier is not infinite as there is a small internal resistance in the transistor. The drawback of the CE amplifier is low input impedance and can be replaced with a FET amplifier which has very high input impedance, making it ideal for amplifier circuits. So as the next part of this experiment, let us discuss about a pictorial diagram. That means a component, a diagram which we are going to position on a breadboard. So this part acts like assume that this is a breadboard. So arrange the components in this way. So I'll zoom this so that you can clearly see this. Okay, see this. See that there is an RA and that means 38K and 13K is positioned as it is between VCC, and you select the position here, and which you are going to, it becomes a common point for input capacitor and base of the transistor, and one point of the 13K resistor, and another end it will go to the ground. Okay, so okay, let us see the next part. And RE, that means you select the next RE and CE and mount as it is. See, just I am copying this, that's all, no difference. And the collector resistor is also in the same way. Now what you have to do here is take one power supply, set it to 5 volts and connect positive terminal to this line. So this line I assumed as a VCC plus VCC line, and the bottom line on the breadboard as a ground. So this ground connection is directly connected to this. So next what you have to do according to this circuit, see this, the input is the function generator. So I make an arrangement on left side, particularly on your work table, arrange the function generator on left side. Just connect the positive terminal of the function generator to the input coupling capacitor and the negative terminal to the ground. Okay. Now take one CRO and select always the first channel. I am repeatedly telling that every time when you want to see the output, always select the first channel. Now the positive terminal of the CRO connect to the output coupling capacitor and the negative terminal to the ground as usual. So this is the common setup, and please do remember that left side always function generator on the working table, and at the next to that function generator you have to make an arrangement for the power supply. Then on right side, extreme right side, CRO. These are the equipments arrangement you have to make so that you can easily troubleshoot, or the arrangement will be very simple. So after this what you have to do is you have to start the experiment, switch on the power supply, set the input voltage actually it is 20 millivolts. So according to our design it is 20 millivolts. You see that it is 20 millivolts here. So adjust this to 20 millivolts function generator. So initially you don't know what voltage it is. The frequency usually you can set, because that the function frequency counter is available in the function generator. Do not worry about all inputs what it is there. First you connect positive terminal to here and negative terminal to here, switch on this. Then switch on the power supply, set it to 5 volts. After that switch on the CRO. Select the first channel trace and connect the positive terminal to the output. These are the first thing you have to do. Assume that everything is ready, all instruments are working, connections are correct, transistor is connected according to the schematic diagram. Now what you have to do is just remove the positive terminal of the CRO and connect directly to the input, because we are supposed to give the input when the circuit is in working condition. Not many people have observed that they are connecting these positive and negative on a separate place, and they are going to connect, then they will set 20 millivolts, 30 millivolts or whatever it is V in. That is a wrong method. What you have to do is connect the function generator as usually, remove the positive terminal of the CRO, connect here. Now you adjust the amplitude of the function generator and set for what you require. So in this case it is 20 millivolts. Adjust on the CRO, selecting a 20 millivolts per division scale or 10 volts per division scale, whatever you prefer, and adjust the amplitude of the function generator to get 20 millivolts. It's okay? Right, good. Now adjust the function, because we want to check on the first stage itself if the circuit is working or not. That is very important. So you have to find out, in the design it is clearly mentioned that any amplifier, there are 3 stages will be there: low frequency region and mid range frequency and high range frequency. There are 3 ranges will be there in the graph. So always select the mid range, say for example 100K or 50K, something like that. Okay, set that frequency in the function generator. Now you remove the positive terminal of the CRO from this point and connect to the output. Now you can see that on the CRO an amplified output. If you get an amplified output, your circuit connections are correct, and hereafter you set the low frequency, see the amplitude will get reduced. Go for the mid range, the amplitude will remain constant, and higher frequencies it will start to reduce. So that shows that the amplifier is working. Now what you have to do is, see that in this second slide, this is the way of exactly how to plot the frequency response characteristics of the CE amplifier. So this is a tabular column here: frequency, output voltage, then voltage gain, then dB gain. That means 20 log of that VO gain we are going to calculate here. There is a lot of confusion among the students that how to take the rings, where to start the reading, and how many steps. I have seen that practically the many students are taking the readings more than 50, 60 readings. There is no meaning at all. So what you have to do here is, first say that I explained here the tips. Just if you follow these tips, it is more than sufficient for you. Tip to test circuit. Set V input 20 millivolts, select a sine wave, imbalance frequency 100 kilohertz, that means mid-range. Check the output. The gain will be V output by Vn, that means you will get a amplified output here. Here the important thing is, multiply this value where you are getting constant gain. First you multiplied with 0.707, that is equals to 3 decibels 3 dB. This is what we required. Okay, so V out, where you get the constant output, multiplied with 0.707. So for example, if I got for 20 millivolts, if I got 3 volts peak to peak or 2 volts peak to peak, so the output will be V output by Vn, roughly around 100 times I will get it. So multiply that voltage. So sorry, here you have to multiply that 2 volt or 3 volt constant output, where you will get multiplied with this. So you will get an answer for that. So set that answer, note down that answer. It is nothing but 3 decibels here. For example, I got a constant voltage here. Practically I did this. I got this kind of things. I got constant voltage 3 volt peak to peak between 500 hertz to 300 kilohertz. So what I have to do is, first I have to find out F1 and F2. So what is the answer for this? You see that I got F1 is 410 kilohertz, F2 is 367 kilohertz. How I got this? Because first I got the constant voltage multiplied with 0.707, then keeping that amplitude, I adjusted the function generator for lower frequency side. I got it F1 at this position. Again the same, VO multiplied with 7.7. For higher frequencies I got 367 kilohertz. The amplitude will be that much. Hence if false, frequency values are shown. You have to draw. See this as sample example. See, this much of readings are sufficient to plot the graph here. See, I mentioned here, because I got a constant output here, you see that mid frequency range, from where, see that 400 hertz. As soon as I reach the 400 hertz variation, the output voltage is CRO till 400K, I got a constant output. That means VO is constant, and I have noted and multiplied with that value 0.707, and that amplitude I got at near 400, and below that is called as a low frequency range. So you can take some 4-5 readings. Do not take 50, 51, 52 or 60, something like that. You have to quickly skip and reach the proper range. Now you got that middle range, and again you see that in higher frequency ranges, V constant multiplied with 0.707 at around 400 kilohertz, around somewhere around 400 kilohertz, I got that multiplication answer. After that, the gain will start to reduce, because the flat graph is like this, it reduces. So I am somewhere on this higher frequency side. So above this 600K till the 2 megahertz, the amplitude, the gain will start to reduce. That is called as a high frequency range. So keeping this in mind, maximum some 20 range is sufficient, and you can easily plot the graph, and remaining all you can calculate here. I think you understand this technique. And one more important task in this CE amplifier experiment is measurement of the input and output impedance. The input and output impedance, it's a very simple technique. Usually they are spending lot of time for the frequency response readings only. I explained you how to take the readings. Maximum 20 readings is sufficient. Find out the mid-range, take some readings, 4-5 readings, lower frequency side, and some 5 readings on upper frequency side, apart from the mid-range. So what you have to do here is, again, you are assume that your readings are over. Again you go back, connect as it is as in the CE amplifier and set 20 millivolts peak to peak or 20, 30 whatever it is, and see that the output is amplified without changing the shape of the waveform. This condition you have to note it down. Now what you have to do is to find out the input impedance, you have to take a 10K potentiometer. So I wrote here a potentiometer, it looks like something like that, okay. So the two terminals, initially you take a ohm meter, a digital ohm meter, whatever you have, you connect it, one end to the multimeter, two ends you connect two wires and bring the potentiometer, you turn this shaft and bring it to 0 ohms. You understand? Bring it to 0 ohms. Once you got 0 ohms means it is almost short circuit. Now you break this circuit from circuit collector capacitor, base capacitor and function generator. You break the circuit and insert this potentiometer. Now what is the value of the potentiometer in the presetting? Initial pot settings 0 ohms. So it is almost become short circuit. So observe the output on the CRO, you will get an amplified output. Note down the amplitude. You need not to measure the voltage and all those things now. Instead of voltage, what you have to do is how many divisions on y-axis it covers. That's all you have to observe. For example, if I got 4 divisions from peak to peak in the output, I am not bothering about what voltage it is. I am going to bother about how much distance it covers between the peaks. That's all you have to take. For example, if it is 4 divisions, now what you have to do to find out the input impedance, turn the potentiometer slowly and monitor on the CRO. The CRO amplitude on the CRO, the amplitude of the output signal will start to reduce. So I again already that example is 4 divisions. Adjust the part till it becomes 2 divisions. You understand? So that is what I mentioned here. VO divided by 2 means half of the output voltage. Okay. Now what you have to do? Disconnect this potentiometer without touching the shaft and connect these two terminals to the digital ohm meter and measure that resistance, that is nothing but input impedance Zi. Okay, let us see the output impedance. So once the input impedance is over, you are not supposed to disturb any of the output CRO connections. Okay, now just remove this part and connect the function generator to the coupling capacitor. So the work is over now. Let us go for the output impedance. Now what you have to do, turn the potentiometer to maximum. How to check this? We don't know, sometimes you may get whether to turn it in clockwise or anti-clockwise like that. Take a function ohm meter, connect to the two terminals and turn till you get a 10 kilo ohms value on the ohm meter. Now what you have to do is observe that you always do not switch off anything, instruments and everything. Now you are going to connect, once you got 10 kilo ohms maximum initial setting, connect across the output with respect to ground to the output of the amplifier. Again the same procedure. So in the initial stage, when the pot value is 10 kilo ohms, you used to get 4 divisions. For an example I am telling, actually it is 4 divisions here, and now we are going to reduce the resistance slowly, and at one stage this become 4 divisions to 2 divisions. That means the voltage will become half of that. So the work is almost over. Remove these two terminals from the breadboard and measure the ohm. That resistance is nothing but output resistance. So this is what exactly you have to do it. Okay, so I wrote all the information here. So if you want to verify, whenever you will get doubt, you can take a snapshot of this circuit or procedure and you will be very successful in this case. So in the CE amplifier there is one more part is there called feedback with feedback, CE amplifier with feedback. So it is almost the same procedure. First you finish the first part, Then you have to connect a feedback resistor according to the circuit. Then the same procedure, you take it. You need not to measure the input and output impedance in the second part. Okay, just frequency response you have to do it, and you see what difference you will find after connecting a feedback circuit where the bandwidth will be increased. That is the one advantage of the feedback circuit with a resistor. The bandwidth will be increased, and one disadvantage is the gain of the amplifier will reduce. So please note down and sign off from the experiment. It's very simple experiment. You don't afraid of seeing such a lengthy procedure. Okay, if you follow my method, you can finish off maximum within 2 hours in the laboratory for beginners. Okay. Next, what you have to do? Let us see practically how to do this. I'll demonstrate. Just observe that. You will see. Okay. Let us go to the work table and we will start the experiment.